Here we're going to again find the hydrostatic force exerted against one side of a plate, submerged in water, and this time it is a half circle. And the radius of the circle is 6 meters, the diameter is 12. But the depth of the water is only up to a height of 4 on the plate, and so there are still 2 meters sticking out above the water. We notice that we're in meters, and so we are in we're in the metric system. So considering that force is rho times gravity times depth times area, that is the key. Our rho times gravity here is going to be 9,800 newtons per cubic meter. As for the depth, drawing x and y axes can help here. Now, as far as how I decide where to put my x-axis and my y-axis, this shape here is a half circle. When that happens, I'm almost always going to put the axes in such a place that the center of the circle is at the origin. As it happens, that means that the x-axis coincides with the bottom edge of this semicircle, but that's a coincidence. In other cases, I'll often put the x-axis intentionally at the bottom of a horizontal plate. But here, I'm really looking at putting the center of the circle at the origin. And since y is pointing up in the positive direction, when we consider the width of a strip, which we'll need for the area, we can consider that the distance between the strip and the bottom of the plate is y, and so the distance between the top of the water and the strip is going to be 4 minus y meters. And we don't care that the top of the plate is 6 meters up in the air, because all we care about is the portion that is submerged. So our depth is going to be 4 minus y meters. And that leaves us with our area. As we keep seeing, we're going to let the width of the strip be delta y. And here, the length of the strip is going to be 2x, right? The distance from the y-axis to the right edge of the circle would be x. And so the distance all the way across is 2x. And so our incremental area, a sub I, is going to be 2x times delta y. Because we know that this is a circle of radius 6, the width is going to be, the equation that connects x and y, x squared plus y squared is equal to 36. And so that means that x is equal to the square root of 36 minus y squared. And we could use plus and minus, but really I'm focusing on the first quadrant, and we're going to just double that with there. And so our area is going to be given by 2 times the square root of 36 minus y squared times delta y. So our force is then 19,600, that comes from 9,800 times 2, times the integral of 4 minus y times the square root of 36 minus y squared dy, where we can see that y will go from 0 to 4. That's the depth of the submerged portion of the plate. To compute this integral, I would recommend splitting it up. So the force will equal 19,600 times the integral from 0 to 4 and when I split it up, what we're going to do is we're going to distribute the square root, right? So the integral from 0 to 4 of 4 times the square root of 36 minus y squared dy plus the integral from 0 to 4 of negative y times the square root of 36 minus y squared dy. Now you may wonder, why negative y here? Why not just make that a minus? Well, here we're going to need to do a u substitution. For negative y times the square root of 36 minus y squared in that integral, we're going to say that u is equal to 36 minus y squared, and so du is negative 2y dy. We might as well just leave that negative in there. And as a matter of fact, while we're at it, I'm going to move that negative over a little bit and make room to multiply and divide just that integral by 2. As for the other integral, the 4 times the square root of 36 minus y squared. Oh man, if the plate were completely submerged, our limits would go from 0 to 6, and this would be a half circle, and we would just use the area of the half circle and be done with it. But we don't get to do that, and in fact, we're going to have to use a trigonometric substitution. I've taken this as far as I think I should at the moment. What I'd like for you to do is determine the trig sub, and then go ahead and compute the integral and come back when you have the answer. Okay, that may have taken quite a while, but here we are. Looking at our integrand from the integral from 0 to 4 of 4 times the square root of 36 minus y squared dy. That's the one we said was going to need a trig sub. And because our radicand is 36 minus y squared, we know we're going to use the sine function. Fleshing out a right triangle here, the vertical side is y, that's opposite the angle. The hypotenuse is 6. That leaves us with the adjacent side to the angle of the square root of 36 minus y squared. Since our substitution is y equals 6 times the sine of theta, our dy is 6 cosine of theta d theta. And then by looking at our right triangle here, we can see that the cosine of theta is going to be the square root of 36 minus y squared over 6. And so 6 times the cosine of theta can replace the radical, the square root of 36 minus y squared. Our integral then becomes 4 times 6 cosine of theta, and that's from the square root, times 6 cosine of theta d theta, and that's from the dy. As soon as we change our variable from y to theta, we need to change our limits. And so over here I've written a table with x as the input. Remember, x went from 0 to 4. And then using our relationship of y equals 6 times the sine of theta, we have that theta is equal to the inverse sine of y over 6. When x is 0, theta will be 0. When x is 4, we have that theta is the inverse sine of 2/3, and so those become our limits of integration. We have here 36 times the cosine squared of theta as our integrand, and that requires the power reducing formula, so we have 1/2 times theta plus the cosine of 2 theta. That 1/2 is going to interact with the 4 and the 36 from the 6 times 6. We end up with a coefficient in front of 72. Whoa, that's not supposed to be a theta there. That's supposed to be a 1. Whoops, and I want it in green. There we are. Oh, so we are now integrating 72 times the integral of 0 to the inverse sine of 2/3 of 1 plus the cosine of 2 theta d theta. That 1 integrates to theta, so you can see what was happening in my head there. And then the cosine of 2 theta integrates to 1/2 times the sine of 2 theta. Since our limits of integration aren't really great for working with the sine of 2 theta, I used the double angle formula. We know that the sine of 2 theta is 2 times the sine of theta times the cosine of theta. And so just dividing both sides by 2, I can replace 1/2 times the sine of 2 theta by the sine of theta times the cosine of theta. Since we're going to put the inverse sine of 2/3 into sine of theta, cosine of theta, I'll need the cosine of theta. And so I've drawn another triangle here with the vertical side opposite the angle of 2 and the hypotenuse of 3. That's indicating that the sine of theta is equal to 2/3. And then by the Pythagorean theorem, the remaining side is the square root of 5. So substituting gives us 72 times the inverse sine of 2 theta plus 2/3 times the square root of 5 over 3. That's what we get by substituting the inverse sine of 2/3. Substituting 0 into theta plus the sine of theta times the cosine of theta gives us 0. All of that is going to be featured in our final answer here, but we're not there yet because we had the second integral. We identified u was the radicand 36 minus y squared, and so du is negative 2y dy. We multiplied and divided by 2. And then when we integrate, we're going to go ahead and use the power rule. I didn't actually make the substitution, right? I did it in my head. The integral of the radical is really going to give us 36 minus y squared to the 3 halves, dividing by the new exponent 2/3. Since we already had a 1/2, that coefficient becomes 1/3. Evaluating from 0 to 4, if I put 4 in place of y, we have 36 minus 16. The exponent is 3 halves, so we have 20 to the 3 halves. Putting 0 in place of y gives me 36 to the 3 halves. The square root is 6, the cube is 216. And so after all of that, our force is equal to 19,600. We had that, remember, out in front of the whole thing, times the quantity of 72 times the quantity of the inverse sine of 2/3 plus 2 root 5 over 9. And then still inside the brackets, plus 1/3 times 20 to the 3 halves minus 216. Putting all of that in the calculator gives us that F is approximately 9.04 times 10 to the 5th. Couple of things. Number one, be very careful about your parentheses in the calculator. And number two, this inverse sine of 2/3 must be computed in your with your calculator in radian mode. That 2/3 is in radians.